Welcome back to Hardware Unboxed. It is Q&A time, September, part 1. Not much more to say, is there, Tim?
I don't think so.
You haven't got any roasts prepared or anything?
Not this month. I would love to have come pre-prepared to just destroy you, but I've decided to give you a reprieve.
Well, on that disappointing note, today's sponsor spot is brought to you by Thermal Grizzly and their CryoSheet graphene thermal pads, which are an excellent alternative to thermal pastes. They offer very high thermal conductivity with no liquid components, so they can't dry out and therefore don't degrade over time like pastes and even liquid metals. CryoSheet is very easy to use, it's extremely durable, and is available in a range of sizes to suit most applications. I've personally done some high-end GPU testing with CryoSheet, and the results were impressive, very similar in fact to that of liquid metal, but without the mess, and of course, no risk of drying out. So for more information, please check the link in the video description. Alrighty, Tim, we've got an interesting one here. Why do NVIDIA GPUs show less VRAM usage than AMD cards, or I suppose GPUs? The same game and settings, the same VRAM amount, for example, 16 gigabytes of total VRAM. So why are the Radeon GPUs appearing to use more? Well, they probably don't. It's probably not just an appearance thing. They probably are using more. The exact reason for why that is pretty hard to say. We know there are differences, you know, how they handle a frame buffer. We even see like pretty simple stuff like the hardware color, the way they handle that is different. What is it? NVIDIA is generally more vibrant, more saturated, and you get more of a neutral sort of natural tone with Radeon GPUs. At least last time I looked at this, it's just an example of how they differ. Of course, there's also differences, well, in the architecture, the drivers, how that's all handled. Probably the key one would be texture compression, but again, we don't have any evidence that we can point to. It's not like you know AMD or NVIDIA give us that information about how they handle and go about those things. But there'll be architectural differences there. From the testing I've done, it's not significant, and I don't think one's necessarily better than the other. I've seen people claim that Radeon GPUs use significantly more, and that's why they need more VRAM. That's definitely not the case. It's only subtle differences. There may be a game you can point to where one has higher, maybe even allocation than the other, just because of the way that the driver's handling that. But typically, I think it's pretty insignificant, pretty small there. And it's definitely not a situation where Radeon GPUs need 16 gigabytes, where, you know, GeForce GPUs only need 12 gigabytes, for example. It's nothing that crazy.
Yeah. And with games, it's not like there's just the VRAM buffer pool there and the games are deciding exactly what's going into that VRAM buffer. There is a lot of driver components there. As you say, compression is kind of not something that's handled by the game itself. It's NVIDIA going, hey, the game's requesting to do this with VRAM. We're going to handle it in this method, you know, that instruction, that request from the game. And so, yeah, there's going to be some differences in how AMD handles that request compared to NVIDIA, and that's where you see the differences in the numbers if you're looking at like
and even
overlay usage or that.
That's right. When looking at the overlay usage, if you are seeing much larger numbers, let's say on a Radeon GPU, and again, we have established that they do tend to allocate a little bit more, but if the numbers are quite large, look, VRAM allocation numbers can vary, or even usage numbers can vary quite substantially in the same game, same resolution, quality, settings, all of that. It depends on how long you've been playing the game, how much you've explored to get to that area. There's a whole heap of reasons for why VRAM usage can, you know, increase. We do benchmark passes using the same GPUs, and one benchmark pass I might set up to 8.3, and then the next one only 7.7. So there's definitely some variance there. With VRAM usage and allocation.
And using, you know, modern features as well, like frame generation if you're using DLSS on your NVIDIA card but using FSR 3 on your AMD card. You might think they're the same settings, but it's actually utilizing VRAM in different ways, and things like upscaling as well utilize VRAM differently with how many frames they're trying to buffer into the system, which uses more VRAM. So those impact things as well. You have to make sure that your settings are actually identical to then go and compare things like the overlay usage and allocation of those sort of games. So with today's games where, yeah, you might be using different settings on different cards, that has an impact as well. I think when you talked about the color stuff at the start, I'm not sure that's too much of an issue these days. I believe out of the box, NVIDIA and AMD cards look pretty much the same. I think originally a while ago,
I'm talking.
Yeah, they changed like some default settings and stuff.
Okay, so that's no longer a thing.
I don't think so. I'd probably have to look more closely into that.
Yeah, I've not looked in it for years because it doesn't, it doesn't affect frame rate performance. So
that's right.
It's somewhat irrelevant to us. It's just the default presentation. But
Yeah.
anyway. All right, Tim. What do you think about FSR 4 finally being AI based? We've got our AI quota met.
Well, it was interesting to see AMD actually talk about this sort of on the record. Normally, with their future-looking stuff, they hide it away and not really talk about it until it's ready. But it was interesting to hear them come out and say, yeah, we're working on AI-based technologies for this, and we've been doing so, I think they said, for the last 9 to 12 months, which is certainly promising. And we obviously saw with the PS5 Pro launch, they've got their own AI upscaling solution, which has to work on effectively an AMD GPU that's in that console. So you'd be hoping that AMD is working on a similar sort of tech. So yeah, I mean, obviously it's a good thing, I think, that they're sort of moving with the times and they've seen what's been possible with DLSS and XeSS, both of which use AI algorithms to enhance the quality. And both of those solutions, in my opinion, have better quality than what you'd see from FSR. So it's pretty clear that they weren't really improving too much the visual quality we were seeing from FSR over the years. There's been some small improvements, but it's never really been able to catch up with what the AI solutions have been doing. So it really makes sense for them to do it. The question is, why has it taken them until now to get with the times? Because DLSS 2 was released back in, was it 2020 or 2021? I'm not sure. It was quite a while ago now. And so NVIDIA has been using an AI upscaler for many, many years. They've been able to refine it over that time. Maybe it's because Radeon cards don't have as many AI capabilities as GeForce GPUs. So potentially they've tried to not go down that path because their cards can't really handle AI processing. It seems there is some AI capabilities on those GPUs. So I'm not sure how valid that's been. But I think most of the reason that we're only seeing it now is that they've tried this strategy of let's make FSR work well across all GPUs to try and snuff out DLSS, make developers only have to integrate one solution, and that just hasn't worked. Like, it hasn't stopped the momentum of DLSS in any way. If anything, it's probably gotten less competitive over time as people have sort of thinking of DLSS more and more of a selling point of GeForce cards. So it's coming a little late for my liking. I don't know what your sort of thoughts are on that, but
I think that was probably their strategy. And initially, I would have thought that strategy would probably find some success. But to NVIDIA's credit, they just kept making DLSS better and better to the point where they couldn't really head off the DLSS threat that way by an open source solution. So I wouldn't be surprised if that was the plan, but NVIDIA did a really good job developing DLSS over the years and into the feature that it is today. So they're really having to now just change tactic and compete directly with DLSS rather than try and replace it with, a more easily or an easier to integrate, more widely supported feature.
Yeah, and I think Intel has shown with XeSS that you can create a technology that's got different pathways for different GPUs. So XeSS has got their XMX path, which is used on their Arc GPUs, which is the more advanced AI upscaling solution that uses their AI cores on their GPUs. And they've got a couple of different paths. The DP4A one's kind of the main one that's used across all the other GPUs. And that's been, I'd say, pretty successful. They've, in fact, improved the DP4A version quite a lot over the years. So they've kind of shown you can do that. And so it is possible for an FSR4 technology to have a more advanced path, the AI path or whatever, for the GPUs that can do it, and then just revert back to the older versions of FSR for cards that can't quite handle that. Because I think the hardware support is probably a big thing. They've kind of, AMD's maybe been playing catch up a little bit in terms of AI processing across their products, and it hasn't really been needed for too much. Like, you can't say on a GeForce GPU for gaming you're doing all that much AI stuff outside of DLSS. NVIDIA would probably disagree, and they'd like to sell you on a few other features that aren't quite there yet, but that's mainly what you've bought Tensor cores for as a GPU owner, like a GeForce GPU owner. It's been for DLSS, and AMD's been a little behind on that. But, it's good for them to play catch up, but once they do have this AI upscaler available for people to use, they can't just, I guess, wait too long for the next technology to come around to catch up. They need to be at the forefront of these things, not... it was years between DLSS 2 and FSR 2, for example. I think they took too long to get that feature out. With frame generation, again, it was pretty much a year before. They announced their feature just after DLSS frame generation, then took like a year to get it out. they need to be much more proactive with these features so that they're not making their Radeon GPU buys having to wait for ages for features that their competitors are already getting. So, yeah, if they can get up to speed with this sort of thing and keep accelerating, keep innovating, and keep developing the features and not have an FSR situation where they just don't update it for years, then that's going to put them in a really good position. But it sounds like from a lot of those interviews we've seen over the last month that AMD is heading more into the focusing on software. They're improving things like their ROCm feature for developers and that sort of thing, putting more resources into it. So hopefully that means they won't be lagging as far behind with the Radeon features. But we'll see. We can't really comment too much on it because we don't know what it's going to be like. But it's good that they're talking about it at least.
Yep.
This was an interesting question from one of our Discord members. I've never once been recommended a ZOTAC, XFX, or PNY graphics card. With big boys like Gigabyte, MSI, and Asus, how do the smaller guys not get muscled out of existence? This is interesting because I think most of the cards that even we cover on the channel are usually just from the big three brands. We don't dabble too much in like a ZOTAC, for example.
No, not ZOTAC. XFX we do. Some of those brands like PowerColor and XFX and the Radeon sphere, they have a pretty big supporter base, a lot of Radeon GPU owners, which sounds a little funny saying that given the market share difference. But there are a lot of fans of Radeon GPUs that prefer, say, XFX over Asus. So they generate sales that way. I think being an exclusive partner, there are allocation and sort of perhaps discounts and things like that. Certainly they get priority access and support. So that's probably what helps there. This is probably largely closely guarded stuff and there'll be contracts and things that we're not privy to. But yeah, I know here in Australia, companies like XFX, they happen to do really good deals directly with retailers rather than going through sort of the traditional methods that bigger companies would use. So it's probably sort of the ability of the smaller companies to move more aggressively and more directly, whereas you know Asus and that would use typical channels. And yeah, but in recent years they've been able to sell everything they could make, so that's probably helped them a lot. But we did see EVGA drop off though, but that was an NVIDIA direct partner who was by all accounts very successful in America. But
yeah, I think you can underestimate the size of companies like PNY and Colourful and those brands because they're not huge in markets like the US or Australia, but they have quite a large presence in some countries in Asia.
A lot of them are sub-brands as well.
Yeah, so companies like PNY, they're not as small or as uncompetitive with like a Gigabyte and Asus as you might think. They're probably not the same scale as those brands, but they have a pretty big presence in places like the Chinese market.
That's true, yeah.
So you might see even just in some other countries where there'll be some brands, as you say, like they have a better distribution deal. So in one country, you might get PNY cards at a really good rate compared to a Gigabyte or Asus, but then in another country, you might see an MSI that's got a really good distribution deal there. So there's some like regional battles and those sorts of things that go along. So yeah, I think a lot of the reviewers, people that test GPUs, do generally stick to like the Asus, the Gigabytes, the MSIs as well, because at times when there's like a launch of a GPU, especially if there's no like Founders Edition or reference model, AMD or NVIDIA might support you to get a GPU that's more like a Gigabyte card rather than like a PNY card or something. So that tends to help like reviews at the time. But
I think with AMD, they largely sample like Sapphire, XFX, and PowerColor, unless, well, MSI has fallen off a cliff at that point
really
for them.
making them, are they?
But yeah, Asus and Gigabyte probably less likely to get them directly from AMD. But yeah, it depends on the release and what they've got available. But in my experience, Asus prefer rather to sample reviews directly than go through like the review program. They certainly do go through the review program. It's just less likely.
Yeah, it depends what's available. Like some companies don't necessarily have stuff at launch ready to go for sort of the pre-release review period and things like that. So yeah, I don't think there's any reason not to buy like a ZOTAC GPU or an XFX GPU or PNY or whatever. Most of the time, there are some exceptions, of course. There have been some real dud products, so try and avoid those things. But
yeah,
like
Sapphire's pretty much always good. XFX is generally very good, and yeah, so PNY and that probably a little bit different. But yeah, there's certainly brands, Power Color, Sapphire come to mind, of always delivering the goods.
Yeah. So, yeah, you don't have to just stick to the big brands. And certainly, especially with companies, we've already talked about how MSI isn't really making Radeon GPUs at the moment. Even at companies like Asus and Gigabyte, they clearly have a strong focus on making GeForce products. So if you were going to go with an AMD card, the brands you've talked about, the AMD exclusive partners, are probably going to be a little bit more focused on making those products really high quality.
Yeah. You'd hope to get good support from an XFX or a Sapphire, given that's their bread and butter. That's what they do. So
yeah, I mean, we heard from one of the major OEMs that their AMD market share was like 10% of sales or something. It was a very low number. So you can see why they would focus on the GeForce stuff over the Radeon stuff if that's what they're seeing internally. But at a Sapphire, it's 100% Radeon. So they're going to focus on that and make good quality products. So yeah, that helps out a little bit.
Thoughts on what AMD GPU will closely match the PS5 Pro? And I've been well informed that that is a console. Am I right?
I believe yes.
Okay, good. So I know everything I need to know to answer this question. Perhaps 6800 XT or 8600 XT, that yet to be released product, or 8650 XT. Okay, interesting. Well, I'm going to hand that straight over to you, that one, because, console question.
I looked up the specs, hence why I've got my phone out here to read some of these things. So the PS5 Pro, as it currently is believed to be, has 60 compute units of some sort of AMD GPU architecture. So it's probably like RDNA 3.5 or 4 technologies from the upcoming generations. It's also got 16 gigabytes of GDDR6 at 18 gigabits per second on a 256-bit bus. So that's 576 gigabytes per second of bandwidth. And generally, console clock speeds are in the low 2 gigahertz range. Or at least that's where they've been for the current generation consoles. So the RX 7800 XT is a 60 compute unit design. It's clocked at 2.4 gigahertz. It does have slightly faster memory, 19.5 gigabits per second compared to 18 gigabits per second, but the same memory bus. So based on that, you would say that if it was RDNA 3 architecture, that the PS5 Pro would be slightly slower than a 7800 XT, just because there's slightly lower clocks probably for both the GPU and the memory. So again, faster than the 7700 XT because it has more compute units, higher memory bandwidth because it's got 256-bit bus versus 192. And I think that I've seen some comparisons of people saying this would be more like a 7700 XT, but I think memory bandwidth is a really big consideration in modern games. We're seeing more games use memory. It's a unified memory design on the console. So having that higher memory bus probably will make it outperform the 7700 XT. And there's further considerations as well. So consoles are monolithic, whereas the 7800 XT is a chiplet design. So possibly making it monolithic is going to give them memory latency advantages and those sorts of things. Hard to say because we don't really have a clear comparison on that one. And then kind of just talking about rasterization performance there, because supposedly these future architectures are going to be much better for ray tracing, have custom AI capabilities. Sony does implement their own design things into the architecture as well to do things that they want to do. And probably some stuff stripped out of the design as well because they're trying to make it cost effective. So not necessarily all of the features that you would see from RDNA 4 or future generation is in this console design. So this makes it very complicated to compare these sorts of things. And then in addition to this, generally what we see from consoles is a more efficient implementation of a GPU. So while it may have the hardware of a 7800 XT, it'll probably be good enough for gaming performance that's a little higher than that. So maybe that's like a 7900 GRE level of, if you were comparing all the graphics settings, you're configuring a PC game to run in exactly the same level of output quality, it'll probably run more like a slightly higher tier GPU. So all of those things considered, I would probably say from the current generation, it should perform a tier above a 7800 XT, probably, with all things matching up. So the person who asked this question was talking about RX 8600 XT.
I have no idea.
Don't even know what that would look like, but if RDNA 4 was sort of a...
Let's go with 6800 XT, like I said, because that would be put it about where we reckon it would be.
Well, that's right. Yeah, 6800 XT is probably thereabouts. I mean...
A little bit faster, but thereabouts.
Yeah, it depends how mid-range they go. Like, is the 8600 XT going to be an entry-level GPU? Like, what are they naming their cards? Impossible to say there. But I think in the upcoming GPU generation, a PS5 Pro is probably going to be around like an entry level to mid-range GPU, because the 7800 XT right now is a mid-range card, and hopefully in the next generation it will be more of a mainstream entry level sort of thing, and then the PS5 Pro very much the PS5, the base model, kind of like a low end sort of system, which I know console fanboys are probably like, it can't be mid range, like they've just announced it. Surely this is more of a high end product.
Always the case though, aren't they always mid range and then they get shuffled down?
Well, yeah, that's what I was under the impression of. A console has never really been a high end PC equivalent.
What GPU was on the market when the PS5 first came out?
Well, it came out at the same time as the 30 series and the 6000 series. And I think it was about like a 3070 level of performance.
Yeah, that's what I thought.
Mid-range again.
So that wasn't a 3090 Ti?
No, no, come on now. No.
So that's my point. They're always pretty much mid-range, but you get what you pay for, really. I mean, arguably you get a bit more than what you pay for in terms of bang for your buck, because it's a gaming-focused, gaming-specific device. But anyway.
Well, that's where people get caught up on the PC versus PS5 Pro comparison. Are things like, you spec out a system, a PC that's you think has got like a 7800 XT like GPU and a CPU that's maybe a bit faster than what the console's got. You look at the price, it's more expensive. It's like $1,000 or something, right? And people are like, must be good value now. It's like, well, a PC does more things. Now, if you're a gamer, you don't have to use the things that a PC can also do, but it's true that it can do more things. And also, you can't really buy like a PS5 level of hardware. Like, you buy a motherboard, right? It's got all those expansion slots and stuff that they've added in to make it a more capable platform. So you can add in more stuff. It's got more USB ports. It might have faster Ethernet or Ethernet Wi-Fi integrated. I think the PS5 has that, but you can't exactly go buy a motherboard that deletes all the M.2 slots, so you've got one slot like the PS5 that deletes all of the expansion slots, all the USB capabilities.
And you've got the ability to upgrade and all that.
Yeah, so you're paying more for upgradability. The PS5 is an integrated system, so you can't do that at all. So all of those things are complexity that adds to the cost of the system. So when you look at it, you're like, okay, yeah, a PC is more expensive, but even something as simple as a power supply, like you're probably buying a modular power supply that's way more powerful, as in its power output is way higher than a PlayStation console, which can ship with a power supply that's designed specifically for that hardware that may only be 200 or 300 watts. Whereas on a PC, most people are buying 700 watt power supplies, 800 watts, which again, that adds to the cost.
Yeah, and if you buy a good power supply, you can keep that for 10 plus years. So
yeah, exactly. So those comparisons, like it's a fun exercise to sort of say, this is what you would need from a PC perspective to get the level of gaming performance. But I think if there were more gaming focused hardware platforms available, that the cost of a PC would come down. If it was locked to only gaming, if it removed all the expansion capabilities.
Stuff was like a console.
Yeah, exactly. If you were
build your own console.
If you could buy off the shelf the PS5 hardware and you could install Windows on it and play games, it wouldn't cost $1,000. It would cost less than that. Like, that's just, I guess, the reality of it. So, yeah, we'll stick with our PC gaming, I think.
Yes, thanks.
Yeah. All right, next question is, should AMD change their FSR tech to work at the hardware level like NVIDIA and stop support for non-AMD cards to compete more strongly with NVIDIA? It's pretty closely related to what we were just talking about, isn't it?
Yeah, you touched on it. I think the XeSS implementation is probably the best way to go, where they still maintain FSR in its current form, but then have a more advanced hardware-based version of FSR that becomes a key selling point of Radeon GPUs, or at least helps to sell Radeon GPUs, because while we've sat here and we've said it's great that AMD does open source stuff, we're all about, supporting the open source, and that's really what should be pushed. It hasn't helped them compete, and it, in a way, like we've been saying they should do this, but then we've almost been punishing them for doing it. And I mean us and also gamers at large, because again, we've said we want these open source features, right? But then when it's not as good as DLSS, we're saying DLSS is a key selling point of GeForce. So you see what I'm saying? Like
the open source nature is kind of, if that's held them back from making the feature as good as it could be, then you're kind of punishing them for being worse, but also praising it for being open source. And
it falls under the heading of, people say, they want Radeon GPUs to be more competitive, so it makes GeForce GPUs cheaper.
Well, that's right.
And this plays into that again. Like, we want that open source stuff so it supports, the older GeForce GPUs and all that sort of stuff. But it doesn't enrich the current generation hardware that AMD is trying to sell. It's a feature that doesn't really neutralize anything on the GeForce side. It just enables those with GeForce GPUs to use FSR when DLSS either isn't available, whether it's the game support or the hardware support.
We're seeing that with frame generation now. Like DLSS and FSR is kind of more ubiquitous, but the development of FSR 3, which has allowed like a GeForce 30 series owner to use frame generation, is that actually selling people and buying Radeon GPUs, or is that just enabling a 30 series owner to use frame gen until they upgrade to 50 series or 60 series products?
Yeah, that's right. Yeah.
So, yeah, I mean, I think at this point, with the way most games are integrating all technologies at the moment, it's rarer and rarer that we're seeing a game that just has DLSS and no other upscaling technologies at all, or just FSR and no other technologies. I just don't think that GeForce owners are using FSR. So they're putting in a lot of development resources to make it this open technology, but then most of the openness is not actually being used by gamers. Like, you might get a few people using older 10 series or 16 series NVIDIA GPUs that don't have access to DLSS, but that's getting less and less as each year goes on, as more people upgrade to RTX GPUs. And so most people using FSR are people that have got AMD Radeon GPUs or using integrated graphics on things like a Steam Deck or other portable handhelds that are largely, AMD based. So if the main target market for FSR is AMD hardware, then it would make sense to focus that technology on AMD hardware, making it as good for AMD users as possible. And like you said, the XeSS sort of solution of having maybe a fallback or something is probably the way to go. And like we said, it's probably going to require more powerful hardware. So whether it's like an RDNA 4 exclusive feature or it works better on RDNA 4 or something along those lines, it's probably about time that they think about doing that and just selling it as not so much, this will work on everything, but when you buy a Radeon card, you're getting the best features that we've got, the best version of upscaling, the best version of frame generation, and they've also got their driver-based frame gen, which we haven't looked in depth at, the newer version, but they keep working on it, which is good to see. So that's probably what's going to sell GPUs, at least in my opinion. The open source thing, as you say, I don't think has really worked that well.
No, well, again, I think we've polled this. Everyone seems to agree, or the vast majority of viewers seem to agree, and we're certainly of this opinion now that, and we talked about this heaps, I think, last Q&A series, that Radeon GPUs need to sell at what, like a 10% minimum discount, more like 15%, closer to 20% to be a must-have item, because they either lack certain features or the feature quality is just not as good as the competing parts. And again, while I'm not hugely, still at this point in time, not hugely excited about ray tracing, again, there's some good examples of it, but it's not, for me, something I would prioritize as a top-tier feature that I must have on a card. Again, we talked about this last time, there's a lot of even Black Myth Wukong. I'd still probably play that game without it, just for personal preference, prefer the smoothness of real higher frames. So, yeah, DLSS is a key selling feature, I guess is the point I'm trying to make, and it's a feature that we believe is superior to the current implementation of FSR. So if AMD can get FSR to the same level or better, then that's a real reason to buy a Radeon GPU, and it means that Radeon GPUs don't need to be 15% cheaper or whatever. They can get closer to the price parity they seem to believe they can ask for and have been asking for, but haven't been getting. So, yeah, again, I know people will get upset and criticize us for saying that, we're sort of pushing more exclusive features here for Radeon GPUs. But if you want to call it an experiment, for the last few generations where they've had, open source FSR, upscaling, all that sort of stuff, and it just hasn't worked out. It hasn't worked out, really. Their sales aren't good. Their market share has continued to decline over that period. So as much as we hate that exclusive stuff, it does seem like it's the way forward to actually sell products.
Yeah, I mean, it's possible that if they made their GPUs cheaper and went with the strategy that they went with, that they would have maybe gotten more sales, but they kind of went with this, we think our features are awesome, but then also they're kind of not, so people don't buy the GPU sort of thing. So they kind of priced it above where the technologies actually were at,
Yeah, it's
which I
certainly,
think's hurt them. So hopefully with a future gen, they improve their features and make the cards cheaper, so at least get people in the door, and then
makes it more compelling, yeah.
in some future generation when they've got more market share, if they can achieve that, then they can go back to, well, we've got parity in features and that sort of, but we're just talking about stuff that's a pipe dream at the moment. Like, it's, who knows if that'll happen, or
It really is a pipe dream. A more competitive GPU market. I think at this point you would be willing to sacrifice open source for exclusive features to have a more competitive market, right? Because ultimately that's a healthier market for everyone.
Yeah.
Gamers in particular. So we'll wait and see how that all plays out, because they are changing strategy, and we'll know in a couple of generations, well, how that's worked. If it's worked, hopefully it does.
I noticed in the Zen 5 announcement that AMD uses a Radeon RX 7900 XTX to test their CPUs, while nearly every reviewer uses a 4090 for testing. Could this discrepancy partially explain the difference between what AMD expects and what reviewers have found? Radeon GPUs are slower, but they also have less driver overhead. So
yeah, there is a technical reason for why that could be, but no, because, well, the CPU scaling should be pretty similar, right? Like, it's not that one would favor AMD CPUs more than Intel CPUs. There really isn't a reason for that. But AMD did test with an RTX 4090 anyway for the review guide, and we found a similar thing. There was a video, I can't recall now, but there was a video a while ago where I did scaling, and I remember testing the 7900 XTX against the 4090, and while in some instances, because of the overhead, the Radeon GPU was faster, generally it was slower. But we found by the conclusion when we looked at the average data that it really doesn't matter whether you compare AMD versus AMD or AMD versus Intel or whatever. When you compare CPUs, it doesn't really matter whether you use a 7900 XTX or an RTX 4090, as long as you're testing at a low resolution with sort of appropriate quality settings. We found within like a couple of percent the same margins overall. It might have even been 1%. I remember the conclusion being basically, if we reviewed all CPUs using a 7900 XTX, which would get a lot of backlash, we would come to the exact same conclusions. So therefore, doesn't really matter. But yeah, early on in the piece, when I was going back and forth with AMD, which I noted in my 9700X review, that AMD was spitballing like, oh, we've done all our initial testing with the 1700 XTX. We think that's why our results may be different to yours and maybe some of the other media. We're going to start our 4090 testing now. And I sort of laughed at them and said, well, I probably would have led with the 4090 testing, given that, fastest GPU, and pretty much every reviewer is going to be using that. So the 1700 XTX data's not really relevant to many people. It's not really relevant in terms of market share.
Yeah.
And it's not really relevant in terms of it not being the fastest or the best tool for testing CPU performance. So a bit silly there. But look, that's been Zen 5 testing, especially the way AMD handled it from the start. It's just sort of been, one misled direction to another.
And there's no obvious reason why Zen 5 versus Zen 4 margins would have been different on a 7900 XTX. Like, what would have been the technical reason why they were getting the margins they were doing based on that GPU? Like, there's nothing that really a 7900 XTX leverages better on the Zen 5 architecture. That doesn't really make too much sense to me. So, yeah, not an explanation for that. And as you said, I think most people would have been testing with the fastest GPU on the market. I'm sure AMD would love to say the 7900 XTX is the best GPU for 1080p gaming, but it's not really the case. So, yeah.
I mean, the whole Zen 5 thing has been annoying and sort of continues to be annoying. But the reality is Zen 5 is perfectly fine CPU architecture, perfectly fine, works well, does everything it should. It's great performance, great efficiency. It's just not terribly great relative to Zen 4. It's a very minor step forward, I guess is the best way to put it. And that's the reality of the situation. There's nothing whole. It's not. Windows 10, for example, isn't the savior for Zen 5. Like, I've heard people saying that Zen 5 performs much better relative to Zen 4 on Windows 10. Absolutely not true at all. The reality of the situation is that Zen 5 is not a gaming-focused architecture. Never was going to be. And and AMD mismanaged the marketing on it. It's basically what it boils down to. And the reality is Zen 4, Zen 5, very similar for gaming. If tested under the same conditions, you will get the same margins. They're very close. Doesn't matter if it's tested on Windows 10, Windows 11, Windows 11 24H2, administrator mode. And again, AMD tried very heavily to convince reviewers that the administrator mode solved Zen 5's game performance, and that, you know, the same thing wouldn't necessarily apply to Zen 4. But of course, we did that testing, found out that wasn't true. So hopefully we're near the end of this Zen 5 thing. It's just, the reality is Zen 5, not a good step forward from Zen 4 in terms of game performance. That's just the situation. The GSA code updates, different versions of Windows, patches, is not going to change the fact that the architecture is just not gaming focused. All right, would you recommend using AM5 CPUs with any memory faster than DDR5 6000, or is it not worth the trouble? So AMD's, they already came out ahead of time and said with, you know, Zen 5, for example, DDR5 6000 will continue to be, or continue to remain being the sweet spot. So that pretty much answers your question there, really. You know, FCLK 2000 megahertz is basically what they guarantee, well, they don't guarantee, but what they suggest all CPUs will be capable of. Going above that, you're likely to decouple from the IMC from the memory, and therefore you've got to get up to about 8000 to compensate for that in terms of the bandwidth. But a simple way of answering the question is, well, from all the testing I've seen, a DDR5 8000 and DDR5 6000 deliver about the same gaming performance. They're similar overall. Now, you might find some bandwidth-sensitive game where DDR5 8000 is a little bit faster. You might find a latency-sensitive game where DDR5 6000 is a little faster. But overall, based on everything I've seen, much of a muchness. So the simple way of answering this question is DDR5 8000 typically costs around $180 to $190 US for a 32 gigabyte kit.
Yep.
Whereas the 6000 cell 30 stuff that we use, so the pretty low latency stuff, is about $90 to $100.
It's a big price difference.
So you're getting similar performance, much cheaper for the 6000 stuff, and you are going to have less headaches getting 6000 to work. 8000 really should work on pretty much all the motherboards now with the latest GSA code and all that, but yeah, I would just get the 6000 stuff and not worry about it. No, it sounds really cool saying I've got DDR5 8000 memory, but ultimately doesn't really result in much. You've just wasted a bit of money, and yeah, so get the 6000. And that is going to do it for part 1 of the September Q&A series. Hopefully you guys enjoyed it. I always enjoy these series, and I know Tim does. I'm going to speak for you. No,
okay.
No further input required.
Sure.
But yeah, I mean, that's it, right?
I think so.
So we have the YouTube members that you can join. If you want to do that, click the little join button. The rest pretty much explains itself. When you click the join button, you work with all that. You get badges and things and special emojis that you can use, and of course access to the Discord server. And we also have Patreon. So sign up to Patreon pretty much gives you everything. So pick either one of those. We're not fussed which one you use. We just appreciate the support if you want to do that. And if you don't want to do that, then all good. Thanks for watching the video. But that's really going to do it. I'm your host, Steve.
I'm your host, Tim.
See you next time.